Welcome into the Tech Ed Podcast. My name is Matt Kirkner. As our listeners know, I was a space geek as a kid, and I still love everything space. Going all the way back, I wasn't alive for John F. Kennedy's speech where he called the nation to action and said we were going to put a man on the moon, not because it was easy, but because it was hard. To this day, my belief, the second best speech ever made in human history. I'll leave it up to your imagination what the first best speech was, but an absolutely incredible speech. When I was a kid, I was the kid that had the scrapbook of the Mars rover and was cutting pictures out of the newspaper and putting them into my little scrapbook. I've been to the Kennedy Space Center 3 or 4 times, easy. Absolutely love the topic that we're going to talk about today with our guest, who is Dr. Sharon Cobb. And Dr. Cobb is the Associate Program Manager for the NASA Space Launch System. So you know this is going to be a fascinating episode. Dr. Cobb, Sharon, thank you so much for being with us.
Very excited to be here.
Now, I'm guessing somebody doesn't just graduate from high school and become an associate program manager for NASA, right? Is that fair to say?
That's fair to say.
Tell us about that journey and maybe some of the pivotal points along the way.
My father worked in a steel mill in Birmingham, Alabama when I was growing up, and I had an opportunity to visit him in the foundry. We got to go see them pour hot metal into molds and then develop that into different types of materials by working it with machines. And so it was really fascinating to me that you started with something that looked very different from what you finished with. And so I got really interested in the material science discipline, and that has followed with me my entire career. So when you look at all the components that are required to produce the rocket, they are founded on the science and the physics of materials engineering. So we could not do the incredible things we do without really important research that's gone into materials. But in addition to that, a high school guidance counselor recognized that I was liked and was pretty good at math and science. And so she recommended that I go to engineering open houses in a local college. And so that's really what got me interested in engineering. At the time, I didn't know what engineering was. Sure. And so that was a great opportunity for me to really see what I could do with that whole foundry and metallurgy profession that I was just starting to learn about. And so that kind of started me on my path. I ended up going to the University of Alabama in Birmingham and received degrees in materials engineering there. And as a part of that, I got to work one summer at a NASA laboratory with my advisor from graduate school.
Okay.
And so I was working on microgravity experiments, learning how to produce crystals from a molten metal. And we were doing experiments on the space shuttle with that type of experiment.
Right.
And so being able to take away the gravitational force allowed us to understand a lot more about what was going on during that solidification process.
Huh.
And so I got hooked at that point. That summer, I was able to apply and get a job at NASA, and I've been there ever since.
By the way, I love the humble nature about you and the fact that, I got a couple degrees, and then I went on to, and I knew obviously that you were a PhD because the word doctor is right before your name, but I love that humility about you as well. I've got to believe that serves you well in all the work you're doing now with the Space Launch System, and what an incredible time it is to have a career like the one that you have. Let's talk about that. What is the SLS, the Space Launch System, and how is it going to help enable the deep space exploration goals that NASA has?
Thank you for that question. The Space Launch System is really the foundation of the Artemis program. It is the largest, most powerful rocket that NASA has ever built. Wow. And so it is able to carry both crew and equipment to the vicinity of the moon. We'll have other pieces of the architecture for the Artemis program that'll be responsible for taking the crew onto the moon. There's a human landing system the astronauts will dock with and then descend to the surface of the moon. In addition to that, there'll be a gateway, which is kind of like an orbiting space station that'll be around the moon. That'll initially be the habitat for the astronauts, but ultimately what we're trying to do with the Artemis program is put a sustained presence on the moon so that humans will be able to live and work there, learn a lot about what's on the moon, how it got there, is there water, ice, and then learn how humans can live on another planetary surface so that ultimately we can send humans to Mars. It's a lot of things we need to learn before we get there, but what an exciting time to think that there could be humans walking on Mars.
Right. I mean, it's just incredible to think about that. Every step of that, right? First of all, you said the most powerful rocket that NASA's ever developed, which is amazing. the idea that we would have a space station orbiting the moon and have individuals on that space station, and then eventually populate the moon with individuals working right on the surface of the moon. I mean, it really is an amazing time for us to think about the technology and all the vision and all the incredible work that has to go into something like that. You mentioned the Artemis program, and I just want to give you an opportunity to for our listeners, make sure we help them understand exactly what that is. I know you explained pieces of it, but what is Artemis?
So Artemis is NASA's next adventure in space exploration. It includes a number of pieces like we talked about, but it's a multi-phase approach where we start out by making sure that we can safely send the crew back and forth. We talked about the ability to be able to descend onto the surface of the moon. There's a lot of technologies that we have to develop before we can do all that. But the ultimate goal is for us to learn how to live and work on the surface of the moon, with the ultimate goal of taking those lessons and being able to send humans to Mars. So Artemis is a follow-on to the Apollo program.
Okay.
Artemis in Greek mythology was the sister of Apollo. And so it's kind of a nice tie to our history and then where we're going in the future.
Absolutely. So where we're going in the future, really, really exciting, is not going to happen without tremendous innovation, as you suggest, and innovation that is ongoing and taking place right now. So you think about building the most powerful rocket in history. Talk to us a little bit about what that means. What are some of the manufacturing challenges that go along with that, and maybe some of the unique engineering issues that you run into?
Absolutely. We were very fortunate that when we started the design of this rocket, we were able to use some of the heritage hardware from the shuttle program, but we included some advances and some improvements in those technologies. And we're able to use, for example, the first 16 engines that we use in the Artemis program are engines that have flown before as part of the shuttle program. We've improved their performance. We've improved some of the materials. We've added new, more advanced controllers. And so those are the type things that are part of our history that we'll be including in this, but they're more advanced than they were. And as a part of that, once we run out of those 16 engines, we're developing the next set of engines for the next missions. And we're able to include things like additive manufacturing, so 3D printing, or things that we're using on our engines that have greatly reduced the amount of cost, the time it takes to build them, and make them much more reliable. So, for example, one of the parts, just one part on that enormous engine, had 127 welds in it. And by using additive manufacturing, we've gotten that down to 4.
Wow.
So incredible reduction in cost and time, and just one of the examples of the ways that advanced manufacturing are helping us build a better rocket.
Absolutely. One of the things we talk about a lot when we're talking about advanced manufacturing related to 3D printing and additive is the ability, for instance, to use things like hollow fill. So we're taking tremendous amounts of material and weight out of a part and doing it in a way that maybe not only isn't as strong as the part that may have been previously, die cast or machined or what have you, but in many cases even stronger, but way, way lighter. So it's just fascinating what we can do with additive, and not just the additive manufacturing process, but now we think about all the materials we're able to 3D print in with things like carbon fiber and so on, that are recent advancements in technology that are being put to work in the world of space exploration. I think about how manufacturing itself is evolving and some of the things that you talked about. Well, we've got these 16 engines, so we're using some, I don't want to call it legacy technology, but proven technology that we've used in the past. Shows how we're taking one innovation and building on another one. Shows that whatever research and whatever innovation happened in the space shuttle program, in as much as we've moved on now to other technologies and other programs, taking everything we've learned from that program and putting it to work in Artemis and in the work that you're doing. And then we think about things like controllers, which we talk about all the time in manufacturing, and we think about communication devices and so on. And so many overlaps between the work that you're doing in space exploration and the world of advanced manufacturing. Really speaks to how we can take all of these technologies and how advancements in one space or one area can be applied in others. Are you seeing the same thing?
Absolutely. So advanced technologies are impacting a lot of the things that we're doing in the manufacturing process of the rocket as well. Our ability to inspect parts and do that virtually, as opposed while we're doing the manufacturing, as opposed to some of the ways that we used to have to cut parts apart and do the microstructure and look at them from that standpoint. Just incredible advances that make it so much more efficient, much safer. We know what's in there, the parts, have just been an incredible advancement for us.
Absolutely. So you think about that in the process of manufacturing and in the old days, and I lived through a lot of that. I was in manufacturing for 25 years, and so you manufacture a part and then you send it off to a quality department and they do all their testing and readings, in some cases destructive testing. So we're having to literally like obsolete parts or scrap parts in order to perform our testing. And now we've got the ability to do so much of that through smart technology. So it's whether it's a smart sensor, a smart device, a vision system that is looking right into the manufacturing process, doing a couple things. The first one is that it enables us to find a defect much sooner. And so we're not adding value to a part that's ultimately going to be scrapped, but also learn from that and understand exactly what the root cause of that problem might be. So all of the advancements that we're seeing in advanced manufacturing are being utilized by NASA. Certainly the innovation that's taking place at NASA is going to be used in many ways, in many applications in manufacturing. So all of these incredible crossovers as we continue to advance and innovate. Now, you talked about having all this new technology, all the, and again, I keep going back to this idea that we've got the most powerful rocket in history now. So I want you to take that and compare it back to like the Saturn V rockets that were used in the Apollo program. And how does a rocket today look different from what we would have seen in Saturn V?
That's a great question. So there's a lot of things that are the same. There's a lot of things that are different. The basic physics hasn't changed.
Right.
And so
the laws of physics
the
are the laws of physics.
are still there and they still work.
Right.
So there's a lot of things like the fact that we're using an ablative technology for the heat shield for the Orion spacecraft.
So what does that mean, ablative technology?
It means that you have a sacrificial material on the bottom of the spacecraft that absorbs the heat and burns off.
Got it.
So that it protects the vehicle.
Right.
So with the types of temperatures that you see in returning the crew to the Earth, you can't build a thermal protective system that prevents it. So you have to use what's there and make this ablative technology that dissipates the energy.
Got it. So that would be like the tiles on the bottom of the space shuttle that we remember. Same type, same idea anyway.
Same type idea. But for the rocket itself, we're still using things like a liquid fuel tank and solid rocket boosters, different configuration, different combination of stages, but basically some of the same structures and architectures are there, but we're just using more advanced materials. We're taking advantage of many of the design. Today we have a lot of digital design. Back in the day, a lot of it was done just on paper. Calculations, slide rules, some of those things that your audience probably has never heard of.
Yeah, unfortunately, I remember some of that.
But we're using those kind of tools, and a lot of that helps us do things faster and without a lot of iterations because we can use those digital models to predict what our vehicles, how it's going to fly. And so it reduces the amount of testing that we have to do in a lot of cases. So a lot of similarities in the basic structure of the rocket, but we're using a lot of new technologies to make it better and to improve its intensity and how much power that it has.
And there again, leveraging advancements in certain areas. We call what you just described a digital twin in the world of manufacturing, where we're doing our innovation digitally as opposed to in the physical manifestation of the particular process or the part. So you're doing this similar work in the world of space exploration and innovation and rocket technology and so on, which I find really, really fascinating and interesting. And it's amazing, and I'd be interested in your perspectives on this, but does that increase the speed at which we can innovate? Instead of having to build physical assets or build models of an asset to do all this testing, we're able to do that digitally. Is that already, are you already starting to see the acceleration of the speed at which we can innovate as a result of that?
Absolutely. Our program has seen a huge improvement from that. Back in the days of the Apollo program, we had multiple copies of the space, for example, the Apollo or the space shuttle, and we had to do a lot of testing on those. So it was reproductions. They were destructive in nature sometimes, understanding their strength and those types of things. And so we have done much less of that on this program because we do have the ability to model and to demonstrate the flight patterns and the strength, the materials. The modeling that we do today is so much more sophisticated than it was back in those days. And so we understand the strength. A little side on this, when we did our first launch, our Artemis 1 launch, our flight pattern, our ability to insert the Orion spacecraft to its orbit was 0.03% off of the predictions that we had done with our models.
Okay.
So
So 1 in 1,000, basically,
just
give or take. Yeah.
incredible accuracy that we were
Right.
able to achieve. So just the tools that we have these days have improved so much our accuracy, our safety, and the speed at which we can do these things.
That's absolutely fascinating. And imagine, I mean, having to keep that kind of a tolerance, whether it's in manufacturing or space exploration, incredible precision that's required. I want to talk a little bit more about this whole idea of material science, and in as much as that's, you're spending a lot of time in that space. Certainly, your education pathway was involved significantly with material science. What are some of the more exciting innovations that you're seeing in the types of materials you're using in the SLS program?
So we talked a little bit already about advanced manufacturing and the fact
Right.
that we can 3D print some of the parts that we're using. Another thing that we're doing for the next variant of the Space Launch System is changing out our steel-cased solid rocket motor housings for a composite. And so there again, an innovation in materials is allowing us to build lighter weight, stronger, and more powerful solid rocket boosters. Because of the strength of the composite casing, we'll be able to put those through higher pressures, which gets us more power, allows us to lift more payload, and we'll be increasing the amount of payload that we can achieve from this next variant of the rocket by almost double. So just
Wow.
incredible small changes in materials and technology, but get you a real big payoff.
Awesome. And I can understand, obviously, whether we're sending people to space or we're transporting materials. What are the kinds of materials that would be transported as you're doing this work? So what are you taking to space?
Well, there's a lot of things. If you imagine that you're going to put humans on the surface of the moon for a long period of time, we'll need things like habitats. We'll need supplies. Humans have to eat. Humans
Right.
humans need supplies, lots of food, lots of equipment for the habitats. But then there's a lot more. We want to really understand and do experiments while they're there. So we'll need rovers. We'll need components for that gateway that I talked about. If you can imagine, you won't be able to go to Home Depot or Lowe's during the entire duration of your time on the moon. You've got to either bring it with you or have equipment where you can in situ produce the items that you need.
Right. Well, and I've got to believe that's an application, another one for additive manufacturing, right? So if we can put human beings on the moon, they're living in a habitat, and all of a sudden they need to produce some part, right? I mean, we can't have gigantic necessarily machining centers sitting on the moon. We can't have an entire foundry like the one that inspired your career in some ways sitting on the moon. Additive is going to be a part of that, right?
Additive is a huge part of that. We have a program in something called in situ fabrication and repair. So imagine taking the regolith that's on the moon
Yep.
and extracting your base materials that you need for 3D printing.
Right.
And so you can take your digital CAD drawings with you. And so you can produce a part that you might need to replace while you're on the moon, potentially from the regolith that you're walking around on.
Yeah, I mean, that is so fascinating to me when you think about that. And even, having CAD drawings and CAD that you have with you on the moon, or innovating on Earth, right? And being able to send those digitally to the folks on the moon. That's just so fascinating. And well, I got to believe we're thinking also about them being able to grow their own food, harvest their own food, make it as sustainable as possible, right?
Absolutely. There's a whole program at NASA that is also looking at those types of technologies. But back to the in situ resource utilization, we can even build habitats using 3D printing. Imagine taking the regolith and putting a binder with it and extruding it to make a habitat, a very large 3D printed, not like we currently think of for building parts. Right. But you can produce your own habitat using a large scale 3D printer. And because of the properties of the regolith, you can provide some radiation protection to the astronauts. So technology is going to be a huge game changer in our exploration of the moon.
What an exciting time. And without telling us anything you can, how far away are we from this? If you're back here in 5 or 10 years and we're having this conversation, will we be looking over our shoulder at while there are people up on the moon that are living there? What handicap it for us? What do you think?
I think within 5 years you'll see a sustained presence on the moon. It'll take longer than that for us to build up the infrastructure. A lot of things we have to solve, communications. We've got advanced spacesuits that we're producing to help help the crew live and work there. But I think in the next 5 to 10 years, you'll see a really incredible presence.
So if somebody came to you and said, we want you to be that person that's living on the moon and being part of that presence there, is that something that you would like dream of doing?
There was a time in my life where it was. I'm
Right.
probably at a point in my career where we need to let some younger folks take over this adventure. I think there's great potential. The generation that's out there today, I would say, is the Artemis generation. They're going to be a part of making this happen.
The Artemis Generation. Yeah, I absolutely love that. As far as the skills, the education background, the competencies, who gets to do this? I mean, is this just people that have been through, extensive NASA training and are, our career astronauts and so on, 5, 10, 15, 20 years from now, whatever it is, what types of people are going to be able to live on the moon?
That's a great question.
Yeah.
I think the current model that we have, because the astronauts that fly with us are so heavily involved in flying the missions and the safety of actually landing on the moon. But I
Right.
think as you see this become a much more regular event, that there'll be an opportunity for many others to join us. As you know, there are space tourists in orbit today, actually just launched this past week.
I saw that.
And so very exciting time. This is a time where we will see, I do believe, a lot of investment from the general public. There's going to be a whole industry on the moon, and the more we can start that process and then engage industry, I think the faster that will happen.
And then, in my generation of, growing up and watching this was something that this is something that the federal government did. Not exclusively necessarily, but it was a federal government program. And now so much of space exploration involves a partnership between private companies like SpaceX and Blue Origin and others with NASA, which I think is only going to continue to accelerate innovation. But so it is a much different world than the world not too long after I was born, soon enough that I don't remember, one small step for man and a giant leap for mankind in first person, but certainly have seen it over and over again. This isn't just going to be a small step for man going forward, right? It's going to be a small step or maybe a large step for men and women. I know a huge part of this goal of the Artemis program is to land the first woman and the next man on the moon. How important is that, and how big of a deal is that going to be when it happens?
Well, I think it'll be an exciting time for humanity, whether you're male or female.
Mm-hmm.
I think the idea that diversity brings to the table is everybody has a different experience, everybody has a different background, and the more we can engage a large number of people from different opportunities, from different backgrounds, from different races and genders, the more we can solve problems better. Everybody has a different perspective, and when you bring that to the table, you get the best possible answer. And so even with this next mission, the Artemis 2 mission, which will be sending crew to the moon, around the moon, about this time next year, 2025, it will include one of the most diverse crews that have ever gone. Well, it is the most diverse crew that's ever gone to the moon. It'll include Reed Weissman. It'll include Christina Koch. It'll include Victor Glover, an international partner, Jeremy Hansen. And so we'll have the first woman to go to the moon, the first person of color. So while they won't be landing on this first mission, this will be the most diverse crew that's ever endured an extended exploration to this level around the moon. So really exciting time for the nation, for the world, to see that the people that are going to the moon look like people you know in your everyday life.
And I can tell you, I love the way you started the answer to that question, because we, in several businesses outside of the Tech Ed podcast, what we have found in those businesses is the more diverse our workforce, the more diverse our team. It doesn't matter at every level in the organization, and certainly through senior leadership, you do get different perspectives and you do get different ideas, and you can innovate more quickly, and you can relate to the general public and your customers and your suppliers more effectively. So I really admire the fact that that's a key part of the work that you're doing, and taking these incredibly qualified and incredibly brilliant people and giving them the kinds of opportunities that they're going to have traveling around and eventually to the moon. That's really just the first step, the moon, right? You already mentioned that Mars isn't too far behind that, and then deep space exploration and so on. There's so much we don't know about our universe. I'm just a believer that there's way, way more, whether it's at the quantum level or, across the universe, as small as you want to go or as large as you want to go. We know a lot less than we don't know, in my opinion. So let's dream a little bit about that. Tell us about Mars. Tell us about deep space exploration and the work that you're doing in SLS that kind of coincides with that.
So we talked about a little bit about the rocket being the foundation of this program. Anytime you think
Right.
about exploration, you've got to have a really powerful way to break the bonds of Earth. The gravitational force that we have here is kind of what holds us back. So we've got to solve some of those problems first. But the idea that we can live and work on Moon is a very complex problem. As you know, the trip to the Moon is a couple of days. But when you're talking about going to Mars, we're talking about 9 months at a minimum with the current technologies that we have.
Which really puts it into perspective, right?
It
A couple days
does.
to the moon, but 3/4 of a year to get to Mars, just to get there.
Just to get there. And then you spend any time there and then you have to come back. This is a really long duration project.
Right.
So we really need to understand all the systems. We need to have very reliable human support systems. So there's a lot of technology that needs to be developed before we're ready to spend the time that it takes to get there and then to actually have some time on the surface before we come back. So a lot to be learned, but the incredible advances that we've made in technologies, I think, are going to set us up to be ready to do that. There have been very few countries that have even been able to send robotic landers to Mars successfully.
Right.
So we've got some homework to do, but
Right.
we're headed in the right direction.
It's such an exciting time now, and I know it's an impossible question to answer definitively, but let's look forward 50 to 100 years. I mean, what does that look like? I mean, what would Mars look like? And just dream with me. Obviously, nobody's going to hold you to it, but what could that look like 50 to 100 years from now?
I think you'll see a colony on Mars. We have
Okay.
a lot of industry that's very interested in taking their technologies and innovations and heading that way. When you think about it, it was a little over 50 years ago that we had the first human walk on the moon.
Right.
So you look at the technologies and how they've changed over the last 50 years. Think about 50 years from now, 100 years from now. There is absolutely no reason why we can't have a colony on Mars.
We talk all the time. What I love to talk about is the exponential economy, the idea that products double in price performance every 12 to 18 months, and that, whatever, in looking back over our shoulder and, what we commonly call Moore's Law, and our ability to process information digitally at speed doubles at that same rate. And it's just got all these incredible implications. And then you start thinking about that exponential growth piling on top of each other. In the year 1969, nobody would have dreamed of all the technologies that we have available to ourselves, and God only knows what technologies we'll have available 50 to 100 years from now. But as as you gaze up at the heavens and you realize that we're such a small, teeny tiny part of this incredible universe in which we live, it really is mind blowing. I mean, it's such an exciting time to be a human.
Absolutely, it is. The things that have changed just in my lifetime, it's just amazing to think. It's almost not possible to think about what that reality will be like 50 years from now.
Did you dream as a kid of being a NASA, whether it's an astronaut or working in this kind of a job? Is that something that you even dreamed of, or is this something that just kind of flowed out of your education pathway and the opportunities you had along the way?
A lot of my colleagues were fortunate enough to be around and in the area where some of our moon rockets were being developed. And so they had a lot more opportunity to see what was happening. Lived a little far away from that, but it really wasn't until I was in a classroom when they wheeled in a television.
Hmm.
And at the time, we didn't have televisions in the classroom. I thought, this is something really big. Some real history is being made here.
Right.
And so I think that's probably what piqued my interest, watching the first man land on the moon, take that first step, and just really think and imagine what could be. If we can do this today, what can we do 50, 100 years from now? So that kind of sparked my interest. And then when I had the opportunity to come work at NASA for one summer with a part of an education program, that really made me realize that I could do that too. I could be a part of that.
You could be a part of it. You are a part of it. You're changing the world. You're working around all these emerging technologies, around really, really cool things that we dream about, right? And so, I don't know that anybody at a certain age could have dreamt that, oh my goodness, I'm going to be, this many years from now sitting in a seat where I'm actually part of putting the next generation of Americans on the moon and others on the moon, and creating a potential colony on a place like the moon, after that on a place like Mars. So absolutely incredible career that you're having. Well, let's talk about igniting that spark, right? Because we're igniting sparks a lot differently now and I remember the days of the TV being wheeled in as well. But that was how we experienced the world in those days. And yeah, when the principal came on the loudspeaker to talk about this big deal, or somebody rolled the television into the classroom, we knew that it was something big. We've got to find a whole new way to inspire young people, and especially girls, toward STEM careers and so on. So let's chat a little bit about that as you think about how important it is to have people find their ways into the careers like the one that you've had, Sharon. How do we do that with the next generation of technologists, the next generation of engineering talent, and so on?
It's a real challenge. There are so many distractions, and the world is so exciting. There's so many things that engage kids. And so I would say it's just so important to give kids the opportunity to see a lot of different careers. The whole idea that my guidance counselor sent me to engineering open house, it may not be engineering that is what ignites your passion, but the more opportunities we can give children to come to things like this, to see what's out there, to see what the possibilities are, I think the more likely we are to engage them and keep them. They say that girls tend to get interested in engineering or math or science, STEM type careers about the age of 11.
Right.
But then we've lost them by the time they're 15,
That's
just
true.
because it's not encouraged. So I think we have to continue to engage and bring kids along and let them see, let them visit their neighbors. If there's an interest, explore that interest with them and help them find whether that's something that they might be interested in.
What is that you think your counselor saw in you when they looked at this young Sharon Cobb and said, this is somebody that should be going to this engineering exploration and activity, that got the juices flowing and got you excited about this? What do you think they saw?
I think there's just some natural ability in some people that you're just drawn to one type of education, part of education or another.
Right.
But just because I liked math and science doesn't mean that was the only career path I could have taken. At the
Right.
time, I was also interested in biomedical engineering, and as a part of my engineering degree, I could have had an opportunity to do biomaterials. And so you just have to keep encouraging kids to explore all the possibilities that are out there, because different things resonate with different people. But once you find that thing that's really your passion, it's not work. It's a joy. It's fun to get up and do what I do every day. And so just encourage all kids to really explore what makes them happy and what they can really see as a future that they're interested in.
So let's assume for the moment that you're having a conversation with a girl, whether it's a fifth grade girl, a girl that's maybe a freshman or sophomore in high school, thinking about STEM as a career. What advice would you give that individual on a real personal level?
That's a really good question. I would say just keep an open mind. Just because you see a lot of men in a particular career doesn't mean that you can't be a part of it too. For me, it wasn't about whether there were men or women in this career field that I was choosing, but it was because I wanted to understand, because I really liked and was curious about what I was looking at and wanted to understand more. And so I would just tell women and young girls that are out there that it doesn't matter what you see a career, the people that you see in a particular career. If it interests you, it's something that you too can do. Perseverance is such an important part of success, and just making sure that you find something that you love doing. It doesn't matter what the other people look like that are doing this career. But I will go back to one thing that I think was really inspirational to me as I was coming up through my educational process. One of the labs that I worked in, we had a collaboration with an astronaut that had done very similar research to what we were doing in our laboratory.
Interesting. This is at what point in your education journey?
This was when I was early, when I was doing my graduate work at NASA in the lab. And so her career path had been very similar to what the career path I was on. She had started as in materials. She had a ceramics degree, and she had gone on to do some very groundbreaking research and had, as a part of that, become an astronaut. And so for me to see that a woman that was a few years older than me, but had gone through kind of the same path that I was on and had achieved that kind of success was really important. And I say that to say role models are so important to, especially to women, to see other people that have career paths that they might aspire to do in the future. So while we might not think about helping you meet people that have been in a different career or the same career, I think it's really important that we engage and encourage girls to meet people that might have unusual careers, because it might be something that they too can can find interesting for the future.
As we've heard often on the Tech Ed podcast, I can't be it if I can't see it. And so having those roles as mentors, having individuals that are setting that example that we can look up to, that we can realize, look, I too can do this, really, really important. I've got to believe in as much as that astronaut in that lab inspired you and showed you what was possible. You're doing the same thing, whether you know it or not, for certainly other women and people considering their career pathways. Tell us a little bit about, do you have an opportunity to mentor a lot of individuals in the roles that you're in now?
I do. Over my career, I've had an opportunity to go speak to a number of high school and even elementary school classes. And that's a great way to help people relate to somebody that grew up in their same area, that maybe looks like them, or can offer them some advice and some encouragement to be persistent and to pursue things, and don't let anybody tell you can't do anything, because if you put your mind to it, you can do anything. And then today in my career where I am now, I have an opportunity to mentor rising stars. It is incredible the bandwidth and the intelligence of the generation that's coming up. And it's really exciting to me to see the potential in some of those younger engineers that are coming up through NASA, and to be able to talk with them, encourage them, and talk them through challenges that they have in their everyday life.
And they're going to be the innovators of the future. They're the ones that are going to drive all this incredible exploration, all this incredible work, whether it's to the moon, whether it's to Mars or beyond. So making sure that they've got people like you, Sharon Cobb, that are showing them the way and showing them that it can be done, really, really important. And I think, this whole idea of you spending time and others like you spending time with that next generation of STEM talent and showing them the great opportunities and the great careers, really, really important work. And I appreciate all the advice you're giving to those young people on this topic of advice. We're going to ask you one last question. It's a question we ask everybody that comes on into the studio here in the Tech Ed podcast. We love the answers. It's such great information for our younger generation. We're going to take you all the way back to when you were 15 years old, before the incredible career at NASA, before the doctorate degree, the master's degree, the undergrad degree, maybe even right around the time or before that incredible counselor was showing you this career path that maybe you didn't realize you could have, all the way to that 15-year-old Sharon. And I would love for you to sit down next to that young girl with their whole life in front of them. And if you could give them one piece of advice, what would that piece of advice be?
I think the advice I would give them would be to stay curious, to look for open doors, to open the windows, to look at what's beyond. Curiosity is such an important part of our ability to innovate and to be effective in the future. So I'd say be curious, but also be confident. Don't be afraid. Don't be afraid of the next step. Just keep looking, keep pushing, keep being open to the possibilities that are out there.
Be curious, be confident, open the door, open the window, look out at what is beyond, from somebody, by the way, who spends a lot of time looking at what is beyond, not just the planet Earth and our atmosphere, but to the moon, to Mars, and beyond. And what a great conversation we've had with Dr. Sharon Cobb. You're a fascinating person. You're a humble person. You're doing amazing work, and I really enjoyed learning about that work. And I look forward to watching the results in all these seeds that you're planting, watching them grow into a tremendous innovation, exploration as we create the future. So, Sharon, thank you so much for being with me on the Tech Ed podcast.
Thank you for having me.
What a great conversation. As I mentioned in the intro, absolutely fascinated by anything technology, and even more fascinated for my entire life by anything involved with space exploration. Being able to have this time with Dr. Sharon Cobb, who is the Associate Program Manager of the NASA Space Launch System, a real treat for me. I know it was a real treat for our audience. I want to encourage our audience to check out the show notes. We'll put some great links in there to the work that Sharon is doing and other information about the space exploration program, about NASA. So be sure to check that out. Those will be found at thetechedpodcast.com/Cobb. That's techedpodcast.com/COBB. We have the best show notes in the business, and you will find them there. You can also check us out on Facebook, check us out on LinkedIn, check us out on Instagram, check us out on TikTok, wherever you go for your social media. We are there to reach the current and next generation of STEM advanced manufacturing talent. So find us on social media, connect with us, let us know you're out there. And until you do that, and until next week, my name is Matt Kirkner. I am your host, and thank you so much for being with us on this episode of the Tech Ed Podcast.